Hello, this is Ibrahim again. This video is basically a continuation to the previous video, and I understand that the previous video was a little lengthy and was quite boring, I must say. Maybe. Well, I hope I can make this video a little different. In this video, we'll be talking more about, or we will be coding more than talking. It's very important before we start to be able to distinguish between image detection and image recognition. Image detection is about finding an object in an image. However, image recognition is about finding or knowing or deciding what kind of object is in the image. So yeah, with that out of the way, let's get to coding. Oh wait, before we start, we need to know something. Now so the computer will be able to detect the faces in an image, which what we will be doing now, detecting faces in a given image. For the computer to be able to do so, it has to learn. It has to be trained to detect faces. So we need to give it in a couple of faces, let's say hundreds or thousands of faces. It will extract the features and so on and so forth, just like we talked about in the previous video. Now, luckily for us, we do not have to do that. It's already implemented and it's already done by several other users, programmers, researchers, however you like to name them. And what we will be doing is use something that's already implemented, and that something will make things a lot easier for us. It will be out of the scope of this video to actually do the training because it does take some time. It does take lots of effort. Yeah. I'll be linking in the description the necessary files or the classifier that has been trained, and hopefully, yeah, things will get very simple from there. So let's get to coding now. I'll start Anaconda. I'll be using Anaconda for this demonstration. I've prepared the files that we will be needing, so I'll post this in the description as well. So this is the classifier, the HA cascade frontal face default. So this is basically the result of the training that has been done using the HA approach, the Viol-Agence detection framework, and this is basically as you can see here, frontal face. This is basically the classifier of our frontal faces that they have used. The images that I'll be using to detect the face are basically this. This is 1, and this is 2. Yep, let's get to coding. So the first thing we need is to import CV2, and just to verify that CV2 is actually imported, is installed in our system. Import CV2, no errors show there, so we're good to go. So after we import the CV2, what we need to do is very straightforward and it's very simple, like we've done before. We need to read the image that we want. We've seen this in the previous videos, and we will store the image in, let's say, img equals cv2.imread, and then we supply in the image name. I'm going to use, let's start with me.jpg. Since it's in the root, or it's in the same folder of my source code, I don't have to specify the absolute path. And then what we need to do is we need to import the classifier, the face cascade, and I'm going to name this face CSC maybe. Yeah, I think that's good enough. And then we're going to use CV2 to import the classifier. There is a method to do so. It's called cascade classifier, capital camel notations there, classifier, like so. And then we supply in the name. Since the classifier is the cascade classifier, the hard cascade is in the same folder of my code, I'll just import it as is. I don't have to specify the absolute path and so on and so forth. Yeah. So cascade underscore frontal face underscore default.xml. And if you open the file, it's basically just XML that contains the numbers and results obtained from the training. As you can see, this is basically the dimensions the images used, so 24 by 24, and then the rest of the details here. Now it's important to know this. I'll explain this in a bit. And then, so let's get back to the code. Now that I have imported the image and the cascade, what I'm going to do is going to transform the image to a grayscale image, just for us to work in with one color. So we've seen this in the previous video as well. So we're going to use this, do this using CVT color, sorry, capital C color, like so, and then we're going to supply in the image as well as use the type of conversion that we want to do on the image. So color BGR underscore BGR to gray, like so. Now that we have the image in grayscale, we need to, now this is the most critical part. Now we need to detect the faces. The algorithm or the class to use is called detect multiple scales, multiscale. And this takes in several parameters. Let me just pull up the documentation for this method here, because there are some parameters I need to explain. This is what we will be using. Since we have OpenCV3, we will be using this cv2.cascade classifier, detect multiscale, and so on and so forth. So these are the important parameters here. If you can see, this is the old one, so there are several things that have changed in the new one. So this one here, the scale factor. So basically when you train the system, you've used a certain dimension for the images or for the faces you've detected. So if you add in a new image for the system to detect, so it will be able to detect for that same size. However, for the scale factor, it will tell the system to resize by a given percentage. So say for example, you have a face that's a little further from the lens and it might be a little smaller than the size of the face used in the training. So what will happen, it will shrink the image a little bit until it will be able to detect that this is actually a face. So if it's zoomed in, the dimensions or the face dimensions will probably be within the face. So if you shrink in the image, it will cover the face and hence will be able to detect the face. So basically that's the scale factor. That's in the layman's terms, of course. And the minimum neighbors, let me open the Viola Jones. So there you go. So when you are detecting the face, or when you are training the classifier to detect the face, what happens is this. The block will run from left to right and covers all the image. Every iteration it will scale down. Yeah. So every time it scales, it sort of detects a region that it assumes it's a face. So the second iteration, when it's a little smaller, if it detects the same region again, then it will consider this as a possible feature, as a positive face maybe. And then if, say for example, the first iteration it detected the face, let's say it's a false result, the second iteration will probably not be detected when the block is a little smaller. So at this time it will consider this as a false positive and it will just ignore it. So every time it keeps iterating. So in this case, in this function, if it's 3, if you can see here 3, if it detects the same region 3 times or so, it will consider this a face. Otherwise it will just ignore it. So the higher the number, the less likely we'll be able to detect the face. The lower the number, the higher probability you will be detecting false positives. So if this one was specified as a 0, you will see all of the possible faces that the classifier has detected. So a good number is actually 3. You could go, of course, you could go higher. It does not mean that you can't go any higher, but it's best that you stay between 3 and 6 if you want a good result, that is. Anyways, so basically those are the two important parameters that we will use. So let's keep coding and hopefully it will make things clearer. Now what we need now, this basically detects the faces. So what we need to supply in, this basically is an implementation or a method of the, if you can see here, let me pull it again. of the cascade classifier. So it's a method of the cascade classifier. Our cascade classifier that we have imported is actually called face.csc. So face.csc.detects multiscale, and then we need to supply in the gray image, and then the scale factor 1.1, and then the minimum neighbors. That's I'll specify it to be 4. There we go. So and then this result I'll store it in faces. So this will detect the faces it was able to detect. And then now, since it detected the faces, we need to draw rectangles over the faces that it detected. So that's very simple. Since we have faces, we need to loop through the faces. So this would basically create, return the dimensions of the rectangles, or the points of the rectangles it thinks that the face is in. So in faces, so we need to loop, we need to x, y, width, and the height in faces. And then we need to create a rectangle. It's very simple. In OpenCV, it's actually using the method rectangle, and then we give in the image that we've read, because we want to show the original image, not the gray image, and then we want to draw rectangles over the original image. So the rectangle is basically x and y, which are the points of the rectangle. And in mathematics, you know that if you have the x and y points, you can actually obtain the opposite points, and you simply add x to the width and y to the height, so you will get the opposite points to these points, and so you will be able to draw the rectangle. So this is basically, if we add x to the width like so, and we need to also, this is the opposite second point, is we add the y to the height like so, and then we just need to color the rectangle. In this case, I'm going just to give it probably green color, 255 and 0, and then I'll the width, the thickness of the line, and then that's it. We've done. We need to show the result of our implementation. We saw this in the previous videos. That's basically im.show, cv2.image show, and then we need to title image, and then we need to supply in the image that we've worked on a minute ago, and then we just wait for a key to be pressed to close the window, so that it won't just close on its own like so. And this is a capital, remember camel notations. Let's run this and see what happens. This is the results. As you can see, this is a green rectangle with a thickness of 3. Let's play around with the thickness. I know this is not important, but I just want to show you that we could. Let's play this. Let's add this 255 and 255 like so, that we create a white color rectangle, so it's very thin and it's white. So there we go. We can change. We could try this for the second image. Let me do this like black. Let me have this black, and maybe let's press on the insert key. Let me press it again. So, and if I say this be maybe 5, that's a good one. Invalid syntax. Oh, sorry, made a mistake here. Missed the closing parentheses. And there we go. So it was able to detect the face on this one as well, and that basically is about it. So yeah, I hope that was useful, and hopefully in the next videos we'll look how to actually detect say a stream from the webcam. It's very simple. It's the same process. We just have to read it from the camera. So see you until the next video. Have a good day.